triangles. Have everything you see here from highlighters to protractor, something to write with, etc. Now, I've gone ahead and I've highlighted with our color scheme that the reference angle, 30 degrees, to the side opposite the reference angle, the adjacent side, and the hypotenuse. In fact, or any other time that I'm trying to help you guys out, theta HOA. Watch my 1-minute video, you'll see that there. Now, what I've done is I've put a mark right here that's, well, let's see what this is. We're gonna do what we did in the previous activity 1, we'll do this now. And so I'm going to measure and mark specifically something I think I need to know here. Using the protractor from 0 is a little bit pesky, so I shifted the ruler over so that I'm starting at 1 and then counting up 1 inch and how many that is from there. So this is my new 0, 1 inch, 1 1/4, 1 1/2. This is at 1 3/4 inches. Now we need to make a mark that is 90 degrees up because all of these are predicated upon 90-degree triangles. So I need to have a 90-degree angle be created, and the protractor is the perfect vehicle to do that. So with my center of the protractor, that open hole or the crosshairs or whatever, and then lining up the 0-degree line across the edge of this triangle, I can now go up and make a mark at 90 degrees. And then I'm going to use my straight edge of the triangle, of the compass, my straight edge of the protractor to make a mark. I can already tell that's off. Why is that off? It should be at a 90. Let me redo. Okay, lined up, lined up. Well, it should be parallel. That's the thing I want to get to. These two sides should be parallel, and I see that it's off by a degree, which means my measurements are going to be wrong. That really has me kind of shook right now. Is it a little too far this way? I'm gonna have to fudge it a little bit. It's gotta be perpendicular, but in being perpendicular, it has to be parallel to this line. So sorry, it's kind of on a slant right here. I'm actually good with that line right there because I also noticed something. The 4 and the 3, that's done intentionally. This is 1 inch. 1 inch, and I'm good with that. So I want to have a 1 inch measurement. I want it to make a 90-degree angle right here. And now that all that remains is to measure the middle, like the small hypotenuse. Label this point D. Label this point E. There we go. So I need to label PD, and I need to measure PQ. Okay, so using the inches on the ruler, I measure here. This is perfect because this is 0, not 1. I'm counting up from there. This is my 0. So I'm going to go up 1 and then 2 inches. And then if I go over here and I measure from P up to, what is that, Q, then lining my ruler up, I go up 1 inch, 2 inch, 3 inch. It's almost 3.5. It's actually somewhere between 3 7/16 and 3.5. So I'm going to say this is actually 3 and 15-30 seconds. Oh my gosh. 3 and 15-30 seconds. I'm going to guess 15-30 seconds because when I use my ruler, all of these little markings are 16th inch measurements. So to be halfway between, a 16th would be at a 32nd. So halfway between and not quite halfway. So half would be 30 seconds. I'm going to go 15 just to kind of like gauge it back just a little bit. Now over here, counting up from 0, not 1, I have 1 inch. Even though that's on the 2, it's from 1 to 2. It's 1 inch away. So 1, 1 1/4, 1 1/2. Not quite 1 3/4. Not quite 1 and what is that one? 5/8? No, 5/8 is here. So this is 11/16. It's definitely between 1 and 11/16 and 1 3/4. So I'm going to go a 30-second as well. And I need to remember here, what is 3/4 of a 30-second and then back up 1? Hey Siri, what's 3/4 of 32?
It's 24.
23 then. 1 and 23. I'm being super picky, and I'm doing this for one to let you know you have to be precise. It is a mathematical requirement that you be precise. Now we've got them all measured, marked, and labeled, and then I did our measurements, so now it's time to put them into the table. In triangle PQR, this is big. The length of the side opposite angle P is 1 and 23 30-seconds. The length of the side adjacent, oh, I didn't measure that one. Okay, so here we go. Measuring out here, I've got my 1 inch on angle P. 1, 2, it's almost perfectly 3. For real. Yep, nope, yep, there it is. So 1, 2, perfectly 3-incher line segment. That'd be PR. In fact, I should put PR equals, and I should put QR equals, and then I should put PQ equals 3 and 15 30-seconds. All of them, of course, in inches. Then on the small triangle, small, we have yellow. I didn't highlight that yellow. I need to highlight. So I want the opposite side. That'd be DE, and I measured it to be 1 inch. Then I have PE. I measured that to be 1 inch and 3/4. And then I have, last of all, PD, which I measured to be 2 inches. All of them in inches. Record. You know, they say in millimeters. Get that out of here. We're doing inch measurements. Okay? Now, moving on. Determine each side length ratio using angle P as the reference angle. So if I labeled here and I added the color the way you did as well, that helps us keep things organized, then for PQR, it should be relatively easy on the big triangle to fill out this one. Let's do it by the name of the side as well as the measurement of the side. So the side opposite angle P is QR, and the hypotenuse is PQ. And then I'm going to use 1 and 23 30-seconds. Divide that by 3 and 15 30-seconds. Now I'm going to leave the decimal answer for the next page. Okay, so on the next page we'll talk about their decimal values, but for right now it's just making the fractions. The side adjacent to angle P is PR, and we're going to divide by the hypotenuse, PQ. So that'd be 3 divided by 3 and 15 30-seconds. And then last of all, the side opposite angle P, that would be QR, and the side adjacent to angle P, that'd be PR, would be 1 and 23 30-seconds, divide by 3. Love it. Okay. Now we have PEF. Why F? Construct an E. I think this is a typo. I think this should be a D, because they said so up in the notes and the instructions up there. So that's a little typo right there. This is the small one. Oh, in fact, notice right here, those should match. This should say PDE. Okay, there we go. That way these match. I want these two to match. And so if any change in the letter, that's a typo when they had first created it, and we're making the adjustment. Okay, so the side opposite angle P, that would be DE, over the hypotenuse, PD. 1 to 2. That's an important observation. That deserves a star. Remember that observation. Okay, the side adjacent to angle P, that's PE, divided by the hypotenuse, PD. 1 and 3/4 to 2. We'll study the ratio in their decimal equivalency in the next page. But for right now, we're just writing the ratios down. Last of all, the side opposite angle P, so DE, divided by the side adjacent to angle P, so that's PE. The numbers are 1 to 1 and 3/4. That is this entire page. I'm going to reserve the next video. Oops, get it up there for you. Hold that so you can see it all and pause and record. In the next video, I'm going to show you what these decimals do and how they're related. And in the same way as what we learned from the 45, 45, 90 triangle, there are some nice ratios that we can use to solve similar triangles. and we can apply them to real-world problems as well. So thank you for watching page 541. 542 is next, and in 542, we need all of these numbers from this page. So have it handy, have it on the other side of your page, and let's get going. Thanks for watching this episode. I'll see you on the next one. 542 is next.